In the complex labyrinth of networks, Layer 2 discovery protocols and EtherChannel are the indispensable compass and map. Welcome to this fascinating journey into the heart of networking, where we are about to unravel the significance of these two critical aspects. Let's begin with Layer 2 discovery protocols. Picture these as friendly guides in the vast expanse of networks. These protocols help devices find each other and learn more about the networks they inhabit. It's like having a GPS system for your network. They provide a roadmap, enabling devices to pinpoint each other's locations and communicate effectively. But it does not stop there. They also play a pivotal role in identifying faults within the network, thereby making troubleshooting a breeze. On the other hand, EtherChannel is a bit like the highway of your network. It's a port link aggregation technology that provides a way of taking several separate physical links and treating them as a single logical link. This results in increased bandwidth, providing a smoother and faster journey for your data. It's like having a multi-lane highway instead of a single-lane road, allowing more data to move swiftly and simultaneously, enhancing the overall network performance. But why are these so crucial? Well, in today's world, networks are growing more complex by the day. Businesses are evolving, and so are their networking needs. Layer 2 discovery protocols and EtherChannel help in keeping up with this pace of change. They provide the tools to understand, manage, and enhance these evolving networks, ensuring they run smoothly and efficiently. So, you see, Layer 2 discovery protocols and EtherChannel are not just buzzwords. They are the very foundation of modern networking, enabling devices to discover each other, communicate, and transfer data effectively. They are the driving force behind a network's performance, reliability, and scalability. Without Layer 2 discovery protocols and EtherChannel, navigating the intricacies of modern networks would be akin to exploring a dense forest without a compass or a map. So let's delve deeper into this exciting world of networking in our upcoming discussions. Stay tuned. Configuring Layer 2 discovery protocols is like setting up your compass for an expedition. In the vast landscape of networking, Layer 2 discovery protocols serve as our compass, guiding us through the myriad of routes available, ensuring our data packets reach their intended destination. Let's break down the configuration of these protocols into simple, digestible steps. First, we need to understand what Layer 2 discovery protocols are. In essence, they are protocols that allow network devices to identify each other and learn about the capabilities and interconnections of those devices. Examples of these protocols include Cisco Discovery Protocol, CDP, and Link Layer Discovery Protocol, LLDP. Now, let's dive into the initial setup. For instance, if we are configuring Cisco Discovery Protocol, the first step would be to enable the protocol globally. This can be done using the command CDP run. Remember, CDP is enabled by default on all supported interfaces to collect and share basic information about neighboring devices. Next, we move on to the interface level. Here, you can enable or disable CDP on a specific interface using the command CDP enable or CDP disable. This level of granularity allows you to control where your device sends out CDP advertisements. The procedure for configuring Link Layer Discovery Protocol is somewhat similar. The global command LDP run will enable LLDP on the device. And as with CDP, you can control LLDP on individual interfaces using LDP transmit and LLDP receive commands. Now let's move on to more advanced settings. Both CDP and LLDP allow for the adjustment of various parameters. For example, you can change the frequency of updates by using the CDP timer or LDP timer commands. You can also modify the hold time, which is the period that a device retains information about a neighbor before discarding it, using the CDP hold time or LDP hold time commands. Last but certainly not least, it's important to know how to verify your configurations. Commands like show CDP or show LDP provide an overview of your global settings, while show CDP neighbors or show LLDP neighbors will give you detailed information about the devices connected to your network. Remember, configuring Layer 2 discovery protocols is not a one-size-fits-all process. Each network is unique, and the configurations should be tailored to meet the specific needs of your environment. With these steps, you have successfully set up your Layer 2 discovery protocols. Your compass is now ready to guide you through the network. Verifying your Layer 2 discovery protocols is like ensuring your compass points north. Just as a compass guides you in the right direction, Layer 2 discovery protocols guide data across your network. But how can you trust them if you don't verify they're working as intended? Let's delve into the process of verification. Picture this. You've configured your Layer 2 discovery protocols. You've set up the Cisco Discovery Protocol or Link Layer Discovery Protocol, and you're ready to go. But hold on, before you let your data loose, you need to verify that these protocols are functioning correctly. Begin with a straightforward command, show CDP or show LDP. With this, you'll see the information about the devices connected to your network. If the data doesn't match your expectations, something might be off. Now let's say the information shows up just as you expected. Great, but there's more to verification. Execute the show CDP neighbors or show LLDP neighbors command. This gives you a detailed view of devices directly connected to your network's routers or switches. But what if things don't go as smoothly? What if you encounter issues? Don't fret. Troubleshooting is a crucial part of the verification process. For instance, if the show commands don't return the expected results, check your configurations. Make sure your protocols are enabled and your devices are correctly connected. In some cases, you might need to delve deeper. Maybe your protocols are working, but the data isn't flowing as it should. Here, packet analyzers like Wireshark can be invaluable. They allow you to inspect data packets and identify the source of any issues. Remember, a keen eye for detail can make all the difference when troubleshooting network issues. The verification process might seem challenging, but it's essential. It's your assurance that your Layer 2 discovery protocols are guiding your data correctly. It's your compass check, confirming that your network is on the right path. With the verification complete, you can trust your Layer 2 discovery protocols to lead you correctly throughout your network. Keep exploring, keep learning, and remember, verification is the key to a reliable network. EtherChannel is your map, guiding you to optimal network performance. Now, let's dive into the concept of EtherChannel to understand its role in enhancing network performance. EtherChannel is a port link aggregation technology. What this essentially means is that it combines multiple physical links between network devices into one logical link to provide high-speed links between switches, routers, and servers. This is like having multiple lanes on a highway, allowing more cars, or in our case, data packets, to travel simultaneously, thus increasing the overall speed and efficiency of the network. But EtherChannel isn't just about increasing speed. It's also about redundancy and load balancing. When multiple links are combined into one, if one link fails, the others can still carry the traffic, ensuring that your network stays up and runs smoothly. This redundancy is crucial in maintaining network stability and uptime. Moreover, EtherChannel is smart. It doesn't just randomly distribute traffic across the links. It uses load balancing methods based on source and destination MAC or IP addresses, or even TCP/UDP port numbers. This means it intelligently distributes network load across all available paths, optimizing network performance. Now let's talk about its basic operations. EtherChannel can be configured manually or using protocols like Port Aggregation Protocol (PAGP), developed by Cisco, or Link Aggregation Control Protocol (LACP), which is IEE standard. These protocols dynamically manage the aggregating of Ethernet ports, providing a degree of automation and resilience to your network. EtherChannel is not just a tool, it's a strategy. It's about understanding your network, knowing its capacities and demands, and then using EtherChannel to optimize its performance. It's about creating a network that is not just fast, but also resilient and intelligent. It's about making your network work for you instead of you working for your network. So remember, When you deploy EtherChannel in your network, with EtherChannel, you are not just wandering in your network, you are charting the most efficient course. In the vast world of networking, Layer 2 discovery protocols and EtherChannel are your essential tools. Today, we journeyed through the intricacies of these vital components. We started by understanding their importance, where we highlighted how these protocols make network troubleshooting easier and how EtherChannel boosts network efficiency by bundling several physical links into a single logical one. Then, we delved into the configuration of Layer 2 discovery protocols, demonstrating how to set them up effectively. We also learned how to verify these protocols, ensuring they are functioning as intended. This hands-on knowledge empowers you to not only implement these protocols, but also to confirm they are working correctly. Finally, we explored EtherChannel, detailing its basic operations and how it strengthens network communication. EtherChannel, with its ability to bundle multiple links, offers a boost in network performance and redundancy. With Layer 2 discovery protocols and EtherChannel, you are now well equipped to navigate the complex landscape of networking.